Hello everyone, welcome to Electrical Engineering YouTube channel. Today I will be going to discuss about instrumental transformer and the category under instrumental transformer one by one, and also its working principle and why we use instrumental transformer. In this video I will explain about current transformer. Then the next video I will prepare another topic, that is voltage transformer. So if you like this video, please subscribe and watch until the end of the video. So let's see the definition of instrumental transformer. Instrumental transformer is used to transform high voltage big current of primary system to low voltage small current for the purpose of measurement, monitor and control for protection application. And the other one is instrumental transformer is used to isolate the primary system with secondary system electrically. Instrumental transformer have different function. One, to insulate the relay metering from the primary high voltage system, and the second one is to provide the standardization of relays and emitter to a few rated current and voltage. There are two types of instrumental transformer: current transformer and voltage transformer. Let's see our today's topic, that is current transformer. Current transformer is work in the principle of electromagnetic induction to transform the high voltage current of primary side to low current of the secondary side, used for the purpose of measuring and protection. This transformer current is expressed in ratio. For example, 100 per 5 ampere. 100 means the primary side, the current flow in the primary side, and 5 ampere is corresponding value of the secondary current. So the next topic is parameter of the CT. There are different parameters in the CT. 1, accuracy class. 2, burden class, and the magnetization curve. Let's see the accuracy class. We have sectioned two sections: one metering class and the protection class. Here it requires a good accuracy up to approximately 120 of the rated current. Metering class requires high accuracy class in order to measure the specified limit of ratio error and the phase angle. So according to IEC have different value. For example, if we see 1, the ratio error or primary to secondary of class 1 CT is 1% of rated current of the CT. Protection class. In protection class, accuracy is not mandatory, as a metering class. Require accuracy up to many times of rated current. For example, 5P 20, 10P 20. Here 5P 20 means 5 indicates a percent of error, P indicates the protection class, and 20 is 20 time of rated current flowing through CT, and the secondary is can handle 5% of error. CT is connected in the series with the network. They must therefore withstand the network short circuit current. And the other parameter current transformer is burden class. This burden class is a load or impedance connected to the CT. Secondary is called CT burden. As the CT has to develop enough voltage to push the secondary current through its own internal resistance as well as the connected external resistance. If loads are not connected to the output terminal of the secondary and simply shorted to each other, then there will be no resistance in this one. So if there is no resistance, all current can follow easily. So what do we call this one is zero impedance. At the same CT ratio of 0.5 ohm resistance connected across the terminal of CT secondary, 5 ampere will follow and produce 2.5 voltage, and this may result 12.5 VA burden. If load across the secondary terminal of the CT increase to 5 ohm, here's this one, then the burden also increase to 125 VA. CT cord material should have low reluctance, high permeability, and low loss and high saturation limits. And the other topic of the parameter of CT is magnetization curve. As you see from this topic, under this topic, there are 3 sections of magnetization curve. That is one initial region, the second one unsaturated region, and the third one is saturated region. This initial region is from the origin to up to this one, and the unsaturated region is from this to knee point. The best method to determine CT performance is the magnetization curve. In this graph, the amount of magnetizing current is required to generate an open circuit voltage at the terminal of the unit. Due to the nonlinearity of the iron core, it follows BH loop characteristic curve. Let's see the knee point voltage here. The transition from the unsaturated to saturated region is this transition characteristic make CT not to produce equivalent primary current beyond certain point, and this point decide its accuracy working range. Increasing 10% of the applied voltage will cause 50% increase in excitation current. For the most application, it means that CT can considered as approximately linear to up to this point. The CT is considered as linear. So let's see the other topic of parameter of CT, that is polarity. Polarity is very important when connecting to the relays. They will decide our direction of the protection. When we come here, the idea come to our mind will be the direction we have used to protect the equipment. This is very important point while we are connecting the relay. According to the British standard, it states that at the instant when current flowing from P1 to P2 in the primary side, then the current in the secondary must follow from S1 to S2. The other topic of our today's video is CT secondary should never be open. CT secondary open circuit may result infinite impedance as a secondary and saturate the core. This induces very high voltage in the primary up to approximately system voltage. The corresponding value of the voltage in the secondary will be multiplied by number of turns, since CT secondary normally has much more turns compared to the primary voltage. Here the voltage generated will be much more than the system voltage. This will lead to flashover. At the end, thank you for watching my video. If you like, subscribe for more video. I will be back on the topic of voltage transformer. Thank you.